Alright, Chapter 6, Soldering, Brazing, Welding, and Wearing Faces. Alright, the information presented in Chapter 5 cover the joining metal parts of the process fusion weld in the chapter perceived that did not require fusion and addressed with the procedure follow the soldering, brazing, welding, wear facing procedures rely on the joining dissimilar metals and produce the high strength joints. Additionally, you have the important advantage of not affecting heat treatment or warping the original metal as much as conventional welding. Soldering. Soldering is this method to use the filler metal with commonly known as solder to enjoin two metals without heating them with a metal point. Soldering is valuable to Steelworker because it's simple to fast many of the joins sheet metal for making electrical connections, sealing seams against leakage. Additionally, use the joint iron, nickel, lead, tin, copper, zinc, aluminum, and many other alloys. Soldering is not classified as welding or brazing process because the melting point temperature is below 800 degrees Fahrenheit. Welding and brazing usually take place above 800 degrees Fahrenheit. The one exemption is lead welding that occurs at 621 degrees Fahrenheit. Do not confuse the process of silver soldering with soldering, for this process is actually forming for a form of brazing because the temperature is used above 800 degrees Fahrenheit. The chapter describes the following equipment and materials required for the soldering, basic methods to make soldering joints, special techniques required to solder aluminum alloys. Equipment soldering requires very little equipment. For most soldering jobs, you need a heat source of soldering, copper, iron, solder, and flux. Source of heat use the solder varying according to the method of the equipment available. The welding sources of the blowtorch, the forges, furnaces, some source of the heat used normally that either the heating device or either the heat the soldering coppers. This supply the heat to the metal surface of the metal of the solder. Sometimes heating devices are used to heat the metal directly. With this done, you must be carefully preventing heat damage to the metal and the soldering material. Soldering copper, usually called soldering iron, consists of the forged copper head of the iron rod with a handle, figure 6.1. Soldering iron, electrical screw tip and plug type tip. Handle, non-electrical copper tip. Alright, so 6.2 shows the copper soldering copper heads, tip or point, pointed copper, bit of head, stub, copper, bottom copper. 6 through filing soldering copper to the handle, which made with the wood of the fiber, either forced or screwed onto the rod. Solder heads available to various shapes to show the 3 or more commonly used with the pointed copper with the guide. In general, soldering work stub copper is used with the soldering flat seams. Need a considerable amount of heat. The bottom copper used with the solder seems hard to reach, such as those found with pails, pans, trays, other similar objects. Non-electrical coppers are supplied in pairs. This is done with one copper can be used with the other being heated. Size designation when the coppers refer to the weight in pounds of TWO copper heads. Thus, for reference, pair of 4-pound coppers means that each of the copper head weighs 2 pounds. Pairs of coppers are usually supplied 1 pound and 1.5 pound, 3 pound, 4 pound, 6 pound size. Heavier coppers are designed soldering heavy gauges metals. Light coppers or thinner metals, usually incorrect size of the copper using result either poorly soldering joints or overheating. Filling in thinner coppers, not newly soldering coppers, must be tin coated with solder before use. 6.4 shows a tinning of copper with solder placed on a cake of sal ammonic. Also, coppers must be filled with a retin overheated with any other reason the cause for loss of their soldering coating. The procedure of the filling and the tinning of the copper is also as follows. 1. Heat the copper to a cherry red. Alright, 1. Heat the copper to cherry red. Clamp the copper in vise as shown in figure 6.3. File the copper with a single cut bastard file. Bear down on the forward stroke with a release the pressure return stroke. Do not rack the file. Continue filing tamper side of the copper until they brighten and smooth. Caution, remember the copper is too hot. It's hot. Do not touch with the bare hands. Flow smooth off with the point of the copper. Smooth off any sharp edge. Reheat with the copper until it's hot enough to melt the solder. Rub it each filled side of the copper back and forth across the cake of solid ammonia, shown in figure 6.4. Apply solder with copper until it is tinned. You may rub the solder directly onto the copper. Place it on the cake of solid ammoniac. Do not push the iron into the solid ammoniac because it can split the cake. When solid ammoniac pack is not available, the powdered rosin, instead of the instant place powdered rosin on top of the brick, roll the copper back and forth to pick out the resin. Then place solder directly onto the copper. Commercially prepared soldering salts are also used with the tinning soldering coppers. The salts are available in powder form. Dissolve powder in water according to the directions. Dip the solder copper into the solution, then apply the solder. So 6.5 shows tinning the copper solder placed directly on the copper. 5.6 shows forging a solder copper. Forging a solder copper. Soldering copper may be reshaped, gorging, and becoming blunt Otherwise, the form procedure forging a copper is as follows: fill the copper to remove old tinning into the smooth surface, heat the copper to the bright red. Hold the copper on an anvil, forge it to the required shape, striking it with a hammer. As you reshape the copper, hollow a pair of point. Keep the hollow to a minimum, striking end of the copper. Don't shape too long the taper sharp points because of this cause the copper to cool rapidly. Turn the copper often to produce the necessary squared offsides. Reheat the copper as often necessary during the part of forging. 4. Reheat the copper to the bright red. Use a flat face hammer to remove any of the main hollows as possible. File and tin the copper using previously described procedure. Electric soldering coppers. Electric soldering copper soldering irons are sometimes called the built and internal heating coils. Staller heatings are removable, interchangeable. Timing is basically the same with the exemption that tip usually does not become cherry red. Forging or reshape is not necessary because the heads are easily replaced. Electrical soldering irons are usually in electrical work and other small jobs, especially suited for the type of the work because they do not require auxiliary heating. They can be manufactured as small as a pencil. Gas torches. Gas torches can be used with a combination of soldering heating attachments as direct heat source. The pressure light heating is usually an ideal soft soldering because it delivers small controllable flame. Also must be used effectively to heat soldering coppers. Figure 6-7 shows the heating unit includes fuel tank, regulator, hose, torch, and burns acetylene or MAB gas as a fuel. Presence of oxygen. The tip, torch tip stem is interchangeable with other tips that come with this unit. There are many different types of soldering being used in the industry. Some of the available various forms include bars, wires, ingots, powders, while wire solders are available with or without flux core. Because many of the types of solder available in the chapter only cover the solders most commonly used by steelworkers. Tin lead solders, the largest portion of all the solders and solders of the tin lead group have good corrosion resistance, can be used for the joining most metals, comparable with the soldering process, cleaning most types of flux. Excellent to describe solder of the custody industry state with a content. First example, 40-60 solder means the tin, 40-10-60 lead. Tin and lead alloy metalling characteristics depend on the ratio of the tin to lead. The higher the tin content, the lower the melting temperature of the tin. Also increases the weldability, lowers the cracking potential of the solder. Behavior of tin lead solder is shown in the diagram figure 6.8. The diagram shows 100% of lead metals at 621%, 100% of tin metals at 450 degrees Fahrenheit. Soliders that contain 19.5 to 97.5% tin remaining in the solid unit until they exceed 360 degrees Fahrenheit. Utic composition tin lead stoppers are about 63% tin, so 37% lead. Utic means the point at an alloy seems that all the parts melt at the same temperature. 63-37 becomes completely liquid at 361 degrees Fahrenheit. Other compositions do not. Instead, they remain pasty stage until the temperature increases the melting point. Other than the alloy, for assistant 50-50 solder is a soldering temperature of 361 degrees Fahrenheit. Liquid temperature range at 417 degrees Fahrenheit. Pasty temperature range at 56 degrees Fahrenheit. The difference between solid and liquid. Solders with lower content were less expensive for the primarily use of the cheap metal products other than the high volume solder requirements. Tin solders are extensively used in electrical work. Solders with 60% of the tin more called the finer solders are used in instrument soldering when the temperature is critical. Tin antimony lead solder. Antimony is added to the tin lead solder to substitute some of the tin antimony with up to 6%. Increase the strength of the mechanical property of the solder. Word of the caution: soliders have the high antimony content should not be used on aluminum, zinc-coated materials. They form an intermetallic compound, zinc antimony, that causes the solder to become very brittle. Tin zinc solders. Several tin zinc solders have come to be used in joining aluminum alloy 91.9, 60-40 tin zinc solders. Higher temperature range above 300 degrees, 80-20, and 70-30 tin zinc alloys normally used for the pro-coating solders. Lead silver solder. Lead silver solder usually with the strength of moderately high temperatures required for the reason lead itself to be even it does not normally wet steel, cast iron, copper its alloys. Adding silver lead results into alloys most readily wet steel and copper. For characteristic trait lead silver either proof of these solders respectively. Humidity, corrosion during the storage, relative flow characteristics can be enhanced as well with increased resistance to corrosion. Introducing tin solder. 1% lead silver will require higher soldering temperatures, special fluxing techniques. The use of the zinc chloride base flux uncoated metals recommended between rosin fluxes decomposes rapidly in a high temperature. Tin antimony solder used for the refrigeration work or for joining copper to the cast iron joints. Most commonly used of 95 to 5 solder. Tin cellular solder, the tin silver thread 964, used for the food beverage containers that must be cadmium lead free. Also be used as a replacement of the tin anium solder 95-5 refrigeration work. And then it gives 6 to 1 fixed use soldering, some common metals, brass, tin, copper, rosin, lead, tall, rosin, iron, steel, borax, salt, ammoniac, stainless steel, other nickel alloys, phosphoric acid, galvanized iron, zinc chloride, zinc chloride, and aluminum stearine special flux. These slaughters and procedures used there in a list of the welding materials handled in Navy Fact P433 flux scale. Rust oxide formed on other metal surfaces with exposure to the air. Heating accelerates the formation. Soliders with not adhere to or wet metal and if the pollutants are removed. Fluxes are chemical compounds used to clean and maintain the metal surface during soldering. Properly also retrieve the surface tension soldering, make it a better wetting agent. Fluxes are manufactured in cake, paste, wet, liquid, powder form, and classified either non-corrosive or corrosive. Show the fluxes that are nominally used for the soldering common metals. Non-corrosive fluxes are soldering electronical connection for other works must be free of the trace of the corrosive residue of the resins. Rosins most commonly give the non-corrosive flux. Solid shape of the rosin, inactive of the non-corrosive when heated. The metals provides some fluxing action. Rosin available in powder, paste, and liquid form. Rosin fluxes frequently leave the brown residue. This residue is non-conductive, sometimes difficult to remove. The removal of the problem can be reduced by adding a small amount of turpentine to the rosin. Glycerine is added to the rosin to make the flux more effective. Corrosive fluxes have the most effective cleaning action. Any trace of the corrosive flux that remains in the work can cause a corrosion later. For the reason corrosion fluxes are not used electrical connections or other work where the corrosion would cause serious problems. The most commonly used corrosive fluxes are solid ammoniac, ammonium chloride, or zinc chloride. These fluxes are frequently used in either solution paste form of the solvent. The president evaporates work heat, leaving a layer of the solid flux for the work. The metal reach for the desired temperature for this layer flux melts with the partially decomposed liberates hydrofluoric acid. Hydrochloric acid dissolves the oxide from working surfaces and solder, making them ready for the soldering. Zinc chloride, sometimes called cut acid or killed acid, can be made with the shop as long as the safety precautions are followed. With the prepared zinc chloride, pour a small amount of muriatic acid of the commercial form of the hydrochloric acid into a glass or acid-resistant container, and then add small pieces of the zinc. As they add the zinc, the acid boils the bubbles and resolve the chemical action produce the zinc chloride and hydrogen gas. Keep it adding small pieces of the zinc into the mixture until the liquid is no longer boils and bubbles. At this point, the reaction is complete, and then you dilute the liquid into the container with an equal amount of water. Make enough, only enough that is required, and strain it before use. If anything left over, store it in tightly sealed glass container. Warning: while diluting acid, you always add the acid to the water. Adding water to the acid could result in an explosive reaction resulting in serious injuries. Specific precautions must be taken when preparing zinc chloride. Rubber gloves and full-face visors and aprons are required. Fumes governed with muriatic acid or by mixture of muriatic acid in your health. As you're well exposed with the prepare zinc chloride under the ventilation hood in the open door, opening things outside of the reduced inhalation fume to the danger explosion. Essential for the precaution be taken to prevent flames to spark from coming into contact with liberated hydrogen. Another type of the corrosive flux is known as the soldering salt. Commercially prepared soldering salt is normally manufactured powder form of this water soluble will allow you to mix only with the amount needed. After corrosive flux, have then used the soldering, you should remove as much of the flux residue as possible for the work. Most corrosive fluxes are water soluble, therefore washing work or soap with the water rising throughout the clear water usually remove the corrosive residue. Lessen the damage. You should ensure the work is cleanly immediately after soldering. Soldering techniques. The two soldering methods most often used the soldering, cottering, torch soldering. The consideration applied to these methods of soldering as follows. 1. Clean all surface oxides, dirt, and grease and foreign materials. Use per flux of a particular job. Some of them require the corrosive flux, while others require the non-corrosive flux. Remember, melting point of flux must be below the melting point of solder you're going to use. 3. Heat the surface just enough to melt the solder. Solder does not stick with the unheated surface. However, they should be very careful not to overheat the solder. The soldering coppers and other surfaces to be joined. Heating solder above the working temperature increase the rate of the oxidation chain of the portion of tin and lead. After making solder joint, you should remove as much of the corrosive flux as possible. Heat the joint with a soldering copper and torch until the solder meets the joint. Place the pieces together, remove the solder so the heat. Keep the parts firmly in position until the solder has completely hardened cleanly. Again, the residue that somebody already completes the job. Seams and soldering. Seam soldering involves running a layer of solder along the edge of the joint. Solder seam the joints on the inside whenever possible. The best method to use for process the soldering copper is because to provide better control and heat, cause less distortion. Clean influx areas to be soldered, and the seams if it is not already attacked or grooved, the rivet is otherwise held together to take place. Piece of the work stay with the position, and if the seam does not rest directly on the support that's necessary to prevent loss of heat to the support, and after you have the firmly fastened the piece together inside a metal seam. Heat the area by holding the copper against the work. The metal must absorb the heat enough from the copper to melt the solder. If the solder would not adhere to the holder, hold the copper so on one tapered side of the head is flat against the seam and shown figure 6 times. When the solder begins to flow freely into the seam, draw copper along the seam with a slow, steady motion. Add such much solder necessary without raising the copper from the work. When the copper becomes cold, you should use the other copper to reheat the first one. Change the coppers often necessary. Remember that the best solder seams are made without lifting the copper from the work, without retracting completed work, allowing joint to cool and solder to set before. Soldering a riveted seam, figure 610, 611, and making solder beads. Move the joint when you use the corrosive cleaning joint with the rising in the winter, with rinsing with water, then brushing off the wiping with the clean with a damp cloth. Riveted seams are often soldered to make with the figure 610. Show the procedure for the solder of riveted seams, solder beams, solder shots, sometimes soldering square, rectangular, cylindrical bottoms to make solder beads. Holds the solder against the hot copper to allow the beads to drop on the clean surface as shown figure 611. To solder the bottom seam of the solder beads, you should first flux the seam before dropping it one over the cold beads with the solder into the container and place the hot soldering copper against the seam as shown figure 612. Hold the copper in one position until the solder starts to flow freely into the seam. Draw the copper slowly among the seal of joining the work as it goes. Add the more beads you need to them to reheat the copper as necessary. To heat the electrical soldering copper, merely plug it in. Otherwise, procedure in so much as that you just described. Be very careful not to let the electrical soldering copper overheat. Overheating can burn out electrical element as well as damage the copper retaining. Soldering aluminum alloys. Soldering aluminum alloys is more difficult than soldering many other metals. The difficult arises primarily with the layer oxide. Always aluminum alloys. The thickness of the layer depends on the type of the alloy exposure conditions. Use the proper techniques. Many aluminum alloys successfully solder raw aluminum is usually either solid or with a cast aluminum. Heat-treated aluminum oil is extremely difficult to solder. The aluminum alloys contain more than 1% magnesium. Solder used in aluminum alloys, usually tin, zinc, and tin cadmium alloys, generally called aluminum solders, must use the solder higher holding points than tin lead solders. Even the ordinary soldering, corrosive, non-corrosive fluxes are used in soldering aluminum. First step in soldering aluminum is to clean the surface to remove the layer oxide. Thick layer of the oxide present. You should remove the paint part of it mechanically by filing, scrape the retaining wire, brushing. Then layer oxides can often remove the by core flux, corrosive flux. Remove any of the residual flux from the joint after soldering the finished. After cleaning the flux surface, you should tin the surface with aluminum solder. Apply the flux work surface to the solder. You can tin the surface with the soldering copper with a torch. If you use the torch, do not apply the heat directly to the work surface. Use the solder or to the flux. Instead, play the torch on a nearby part of the work. Let the heat conduct through the metal to work the area. Do not use more heat than is necessary to melt the solder tin to the tin surface. Work the aluminum solder well into the surface. After tinning and surface, the parts are sweated together. Another procedure, you can use the solder aluminum alloy tin surface with aluminum solder with a regular tin lead solder. The tin to join the tin surface with the procedure can be used with the shape of the parts that prevents the use of the sweating method or demands a large amount of solder. When you use the tin lead flux solder aluminum solder, you don't have to use the flux. After soldering is complete, you should clean the joints with the wire brush, soap, water, emery cloth, and ensure that remove all the flux in the joints, since any of the flux will cause corrosion. Alright, brazing is the process of joining metal with a heating base metal with a temperature up to 800 degrees, adding non-ferrous filler metal with the metals below the base of the metal. Brazing should not be confused with brazing welding. Even though there are two terms over interchange, brazing and filler metal is drawn with a joint capillary action. Braze welding is distributed by tinning. Brazing is sometimes called hard soldering on it. Silver soldering because of the filler metals are there hard solders with silver-based alloys. Both processes require distinct joint design. Brazing offers important advantages over the metal joining process. Does not affect the heat treatment of original melt as much as the welding does, nor does it warp the metal as much. The primary advantage of the brazing, it allows you to join dissimilar metals. Equipment brazing requirement: 3 basic items you need: the source heat, filler, metals, flux. In the following paragraph, these items discussed. Heating devices. Source of the heat depends on the type of amount of the brazing required during doing production work on a piece with all small enough they can put into the furnace and braze at all at once. Individual torches can be mounted in groups for assembly line work, or you can individual axes and maximum map oxygen torch to braze individual items. Filler metals. Filler metals use the brazing down. Fierce metal with the alloys have the melting temperature below the joining. Base metal with above the 800 degrees. Filler metals must have the ability to wet and bond with the base metal and have stability, not be excessively volatile. Most commonly used filler metals are silver-based alloys. Brazing filler metal is available to rod, wire, performed in powder form. Brazing filler metals include the following 8 groups: silver-based alloys, aluminum and silicon alloys, copper, zinc, brass alloys, copper, phosphorus alloys, gold alloys, nickel, oil, and magnesium alloys. Brazing process requires use of flux. Flux is a substance added to the metal surface to stop the formation of the oxide. Similar contaminants that are formed during brazing process. The flux increases the both flow of the brazing filler metal and its ability to stick to the base metal. Strong joint and brazing filler metal to the immediate contact with joining base metal permits the fills penetrate with the porous metal. You should carefully select the flux. Each of the brazing operation, even the manufacturer will specify the type of the metal brazed with the flux. Following factors should be considered when using flux: base metal or metals used, brazing filler, metal used, source for heat used, flux available in powder, liquid, paste form. One method of applying flux in powder form is to dip the heat end of the brazing rod into the container in powdered flux. Allow the flux to stick to the brazing rod. Another method is to heat the base metal slightly and sprinkle the powdered flux over the joint, allowing the flux to partially melt and stick to the base. And sometimes it is desirable to mix powdered flux with clean water, distilled water to form a paste. Flux is either in the paste liquid form can be applied with a brush to joint. Better results occur with the filler metal is also given in a coat. The most common type of flux is borax or mixture of borax with other chemicals. Some of the commercial fluxes contain small amounts of phosphate, halogen salts of either iodine, bromine, fluorine, chlorine, or acetane. Prepared flux is not available. A mixture of the 12 parts of the borax and 1 part boric acid may be used. Warning: nearly all fluxes give the off fumes that may be toxic. Use them in the well ventilation spaces. Joint design. Embracing filler metal is distributed capillary action require the joint to have a closer tolerance, good fit with the procedure for the strong bond. Bracing has 3 basic joint design: butt, lap, and scarf. The joints are found in flat, round, tubular, irregular shapes. Lap joint is one of the strongest, most frequently used joint phrasing, especially with the pipework. Primarily disadvantaged lap joint is to increase the thickness final product. Maximum strength overlap should be at least 3 times the thickness for the metal. 1/1000 of an inch or 2/3000 of an inch clearance between the joint members provide with the greatest strength with silver-based phrasing filler metals. You should take precaution to prevent heating expansion from closing joints at initial closing tolerance. 6/13 show the 3 types of joining design from the hip of the lap joint, a butt joint, and a scarf joint. Butt joints are limited to the size of the thickness section. Maximum joint strength and possible butt joint strength with maximized maintaining joint clearance of 1/1000 3/1000 of an inch. Finished edge. Brazed edge of the joint must be perfectly square to maintain uniform clearance between all parts of the joint, and butt joints are usually used wherever the double thickness of the lap joint undesirable to double the metal thickness objectionable. Need more than strength of scare face joint with a good choice. Scareful joints provides increased area of the bond without increased the thickness of the joint. The area of the bond depends on the scarf angle of the cut for the joint. Usually in the area of bond 2 or 3 times with the butt joint is desirable. Scarf angle of 30 degrees give the bond area twice the 90-degree butt joint, and an angle of 19.5 degrees increase the bond's area 3 times. And this shows the joints designed to produce good grazing results. You should have the butt, lap, modified butt, modified lap, modified butt, lap, butt lap, pierced, butt, lap, modified butt, modified lap, pierced, butt lap, modified butt lap. 6/15 some wells designed that have been prepared brazing. Some poorly designed joints shown as comparison. Good, poor, good, poor. Figure 614 shows the variation of butt lap. The joint is designed to produce the good grade brazing result. The comparison of good and bad design joint is shown in figure 615. Brazing procedures. Procedure for the brazing very similar. Bravely oxycelling welding. The metals needed to be cleaned with either mechanically, chemical, or combination of both to ensure the good bonding. Two pieces must be fitted properly and supported to prevent voids of joint axle movement during the brazing cooling operation. Surface preparation of the metal must be cleaned and capillary action to take place with the necessary chemical cleaning. Surface is dipped in acid. Remove the acid, washing the surface with warm water for mechanical cleaning. You can add steel wool, file, or abrasive paper. Do not use emery wheel or emery cloth. Alright, then we show the brazing a butt joint. You have the brazing routed torch tip, the brazing filler metal through the complete thickness, and they show the brazing filler metal liquid flux, brazing filler metal in the joint, torch tip. Work support. Mount of the work position, fire bricks, other suitable means support, necessary clamp to the important recover the joint, move the during the brazing proper finish, bound will weaken, subject to failure. Fluxing method of the application vary depending on the form of flux. You either the tap of the metal, either the air brazing, refer to the material flux previously described as extremely important flux is suitable for the job. The next step is to heat of the part, brazing. The next step is to heat of the part to correct the brazing temperature, adjust the torch flame oxygen to the neutral flame because the flame goes best, result of the under normal condition, reducing flame produces an essential, neat looking joint, but strength is sacrificed. Oxidizing flame will produce a strong joint, but has a rough looking surface. The best way to determine the temperature of the joint is you heat the watching the behavior of the flux. Flux dries out with the moisture. Water boils off at 212 degrees Fahrenheit. Flux turns to milky color, starts to bubble about 600 degrees Fahrenheit. Finally, it turns to a clear liquid at about 1100 degrees Fahrenheit. This is just sort of brazing temperature of the clear appearance of flux. Indicate the time of starting adding the filler metal. The heat of the joint now the flame should melt the filler metal when the temperature aligns to their proper temperature and alignment are proper. Filler metal spreads of the metal surface into the joint and by capillary action. Good bonding ensure the filler metal penetrates complete thickness of metal. Figure 6/16 show the good position of the torch filler metal with the brazing butt joint. Stop heating as soon as the filler metal has completely covered the surface of the joint with the lap of the joint. Let the joint cool slowly. Do not remove the support with the clamps. Move the joint into any way until the surface is cool. The filler metal has completely solidified. Finally, clean the joint after it has cooled sufficiently. This can be done with hot water, but be sure to remove all the trace flux because it can erode the metal. Except the metal left on the joint can be filed smoothly above the described procedure of the general one, but applied with three major types of brazing: silver, copper, alloy, aluminum. Difference being base metal joint and composition of filler metals. And that shows an ASTM chart. Alright, silver brazing. Often when we call for the silver brazing table 6.2 list different types of silver the brazing alloys with the characteristic proper way to apply silver the brazing with the tubing of the silver alloy shown in figure 6.17. This is practical, the economic way of adding silver alloy using production line system. Another method of the brazing by using pre-placed brazing shims as shown in figure 6.18. Coming to each job varies, however the experience you can become capable of selecting proper procedure to produce the quality brazing. Brazed welding is a procedure joining two pieces of the metal in very similar fusion welding, except the base metal is not melted. The filler metal is distributed onto the metal surface by tinning. The brazed welding often produces bonds that are comparable to those by fusion welding without destruction of the base metal characteristic. Brazed welding is also called bronze welding. Brazed welding has many advantages over the fusion welding, allowing the joint dissimilar metal to minimize heat distortion, reduce extensive preheating. The other side of the effect of the brazed welding elimination stored up strength that often present fusion welding. This is extremely important in the repair of large casting. The disadvantage of lost strength, but subject to the high temperature of the inability to withstand high stress. Equipment need of the brazed welding. Basically, inorganically, the equipment used for the brazing, sim of the brazed welding usually require more heating of the brazing. Oxymap is recommended. Our figure 6.17 shows brazed joints designed to pre-place silver aluminum alloy rings. Aluminum alloy form almost perfect fillets. No further finishing is necessary. R618 shows a mechanical tool bit shown with a carbide insert of the braze and the tool bit botting using pre-placed bending filler metal shim. Carbonite insert brilliant brazing filler metal shim stock. A cutting tool body, completed brazed joint. And then shows the picture of a copper alloy brazing filler metals. Filler metal. Primary elements of brazed welding are copper, zinc. The elements improve the ductility, high strength with a small amount of the iron, tin, aluminum, magnesium, chromium, lead, nickel, silicon added with an improve the welding characteristics derive the aiding deoxides welding metal with the increasing flow action increases the chance of fusing. Table 63 lists of some of the copper alloy brazing filler metals and their use of the most commonly used the brass brazing alloy naval brass. The selection proper brazing filler metal depends on the type of these bases metals. Flux is proper fluxing essential to braze welding. If the surface metal is not clean, filler metal will not flow smoothly, even over the welded area. Even after the mechanical cleaning, current oxides often remain and interfere with the flow of filler metal. If the correct flux eliminates these oxide, flux may be applied directly to the welded area. It can be applied to dripping the heat end of the rod into the flux. One of the flux sticks up to the rod. It can be transferred to the welded area. Pre-flux brazing welding rod is available and eliminates the need to add flux during welding. Alright, brazing welding procedure. Edge preparation. Essential brazed welding edge. Thick parts be beveled with grinding, machining, filing. Not necessary to bevel to thin parts 1/4 an inch or less. The metals might spread bright and clean the undesired weld at the top of the joint. Cleaning the file, steel wool, abrasive paper removes most foreign material such as oil, grease, and oxide. Give the proper flux complete with the process of the permits for the tanning of the occur. After you prepare the edges of the part, need to align with held in position brace welding. The rest of the can be done with a clamp tack weld with the combination of both. The next step of the preheat with the assembly reduce the expansion contraction of the metal during welding. Method we use depends on the side of the casting assembly. When preheating is completed, you can start with the tinning profit. Adjust the flame of the torch to the slightly oxidized flame flux joint. Thoroughly experience what you will find in one or more using more flux during the tinning process produces a stronger weld. Apply heat to the base metal until the metal begins to turn red. Metals, some of the brazing rod until the surface allow it to spread along the entire joint. You must have it to add more filler metal to complete the tinning. Figure 619 shows. 619 shows the brazing cast iron use the backhand method. The torch, the flux, the filler metal, the direction of the weld, the tinning, and the penetration. Sample the tinning being with the backhand method. Welding temperature control is very important. Base of the metal is hot, but the filler metal bubbles run around. Leak beds from the water with the hot pan filler metal formed with the lifted bubble that runs out of the metal. Then base metal is too cold. After the base metal is tinned, you start with adding beads and filler metal to the joint. Use slight circular motion. The torch runs beads as you would regular fusion welding. Progress keeping adding. Flux to the weld requires several passes to be sure that each layer is fused with the previous one. After you've completed the brazed welding operation, heat the area around the joint on both sides for several inches. This ensures the even rate of cooling. When the joint is cool, remove any excess flux, any of the other particles of the tip, wire brush, or steel wool. Wear facing is a process you can apply overlay special ferrous, non-ferrous alloys to the surface of the new old parts. The purpose is to increase the resistance, abrasion, impact, erosion. If you're taking other properties, all wearing faces can be used to build up the undersized parts, often called the hard facings, resurfacing, hard facing. As a steelworker, there are three times when you're required to build up some wear face metal parts from various types of construction equipment. These parts include cutting edges, scrape the dovers or parts, sprocket gears, shoveling, and clam sheath teeth. May even wear face new blades or shovel the teeth before they put in surface in the first time. There are several different methods of wearing face, but in this discussion only cover the oxygen gas process of wear facing. Wear facing provides a means of maintaining sharp cutting edge of the reduced wear between metal parts. It's an excellent means of this reducing maintenance cost for downtime. These other advantages of wear facing need to increase service life with a high efficiency equipment. Wear facing oxygen gas flame is many of the respects similar to the brazed welding. Wear face metal consistently consists of high carbon filler rods such as high chromium carbonide W alloy. When sometime incident with the surfacing alloy is required in either event, the wear surfacing is processed in several layer of metal. One composition is bound to the surface of the metal and another composition. Process of the hard surfacing is suitable for the alloy carbonate and stainless steel as well as the bottom with the cast iron with the non-tempered aluminum, copper, brass with the bronze, the metal point with these materials prohibited use of the hard surfacing process. It's a possibility to increase the hardness of aluminum by applying with the zinc aluminum sided and surface of copper brass and bronze improve in their wearability by the overweight. They work hardened bronze, carbon, and alloy hot tool seals may be surface hardened, but they are other difficult due to the frequently development shrinkage of the chain cracks. If you do not surface these materials, they should be in annealed, not a hardened condition. Necessary heat treating hardening can be accomplished after surfacing operation quench for the part, oil, and not water. wear facing materials. Surface operation, either the copper-based alloy filler metal provides relatively surface work. Soft surface working hardening bronze is soft wear applied, give the excellent resistance against friction wear. Other types of alloys available to produce surface that is corrosion wear resistance. High temperature wear facing materials produced with many different manufacturers thereby these source. Filler alloys, you select the particular surfacing job, meet the Navy specification. Two types of hard surfacing materials in general, either the Navy and iron-based alloys and tungsten carbide. Iron-based alloys, the material contain nickel, chromium, magnesium, carbon, and other hardening elements that are used in a number of applications requiring varying degrees of hardness. Steelworker frequently works iron-based alloys, where he builds resurfaces parts of the construction equipment. The tungsten carbide uses build-up and wear resistant surfaces of the steel part of the tungsten carbon, one of the hardest substances known to man. Tungsten carbide can be applied to form insert a composite rod, insert not melted or welded or brazed to the base metal, shown in figure 618. The rod is applied with the same surface technique as used with the oxy gas, is slightly carbonized and flame adjusted necessary. Wearing face procedures, proper preparation, metal plate with an important part of the wearing face operation. Make sure scale, rust, form, material are removed from the metal surface. You can clean the metal surface of the grinding machine. The clear shipping edge groove of the corner of the recess of the be well rounded to prevent base metal overheating to provide good cushion. A wear facing material applied to the forms a thin layer over the base metal. The thickness of the deposit usually is 1/16, 1/8 of an inch for the seldom over the 1/4 of an inch. If the generally deposit a single path, wear is extensive and it may become necessary to be used a build-up rod before. Wear face if there's doubt whether when you the build-up rod, you should check with the leading petty officer. Preheating part of the requiring wear face preheated with a neutral welding flame before surfacing. You should use the neutral flame about 800 degrees Fahrenheit and do not preheat with the higher temperature for the critical temperature of the metal or a temperature that can cause the formation of scale. Application in general. Storage manipulation wear facing procedures similar to brazing techniques have a high temperature for the 2200 degrees Fahrenheit. Nestle wear facing tips around with two sides larger than normally used. If you're going to heat a small area of the part with a sweeping torch, moving the surface over the base metal takes the sweating and wet appearance, and then when the surface over the base metal in this condition, bring the end of the surfacing alloy into the flame, allow it to melt. Do not stir the puddle, the alloy, let it flow. When the surface area has been properly sweated, the alloy flows freely over the surface of the base metal. Being able to recognizing sweated surfaces is essential for surfacing. Sweating occurs when you heat the steel over the carbonizing flame, and the white temperature for the carbonizing extreme thin layer of the base metal with approximately 1/1000 of an inch thick. Carbonized has the lower melting point with the base metal. As a result, it becomes liquid while underlying metal will remain solid. The liquid provides medium flowing. The filler melts all over the surface of the base metal. Liquid film is similar to the surface of the same. The purpose of thin surfaces inside and brazed welding, When you heat the steel with a carbonizing flame, it first becomes red. A heating continues with the color become the lighter and lighter until the bright witness is attained. Point of the thin film liquid carbonized metal appear on the surface of the alloy. Adding the time flows for the oversweeted surface to absorb the film carbonized metal with the surface condition not difficult to recognize, but you should make sure several practice passes before you try wearing face the first time. When you use oxygen gas torch using for the surfaces and chromium cobalt, the torch flame should have an excess fuel gas feather for about 3 times as long as the inner cone, unless the excess fuel gas flame is used with the proper base metal surface. The condition cannot be developed without this condition. Surface alloy does not spread over the surface part. Alright, show the 620 show the greater blade, the hard surface material applied to the cutting edge. 620 show the greater blade and deposit with the hard facing material applied along the cutting edge. A greater blade is usually wear-faced electronic arc process. The electronic arc process is not available. You may use the oxygen gas torch. Well, the materials handbook Navy Fact P433, an excellent source of information wearing surface construction equipment. Alright, Chapter 7, Shield Metal Arc Welding and Wear Facing.